To do this one, it's not going to be hard. We just have to remember what the derivative of cotangent is. Also, don't be intimidated by the letter theta here. It's just, instead of dy dx, we're just using a different letter for x. We're using theta. So what is the derivative of cotangent again? The derivative of cotan x, say, it's just minus cosecant squared. It's a little bit similar to the derivative of tan x, right? The derivative of tan x is secant squared x. That's not relevant here, but I just wanted to draw the analogy there. So we're going to need to remember the derivative of cotangent here. So let's see what this derivative here is. dy d theta is going to be, well, the 3 just comes out front. And we're ignoring the n theta. We're using chain rule. We're kind of ignoring the n theta here. Derivative of cotan, well, let me say this here. Do you remember this concept? If we know that a basic derivative like cotan x is that, if you know the basic derivative, you can do the cotan of anything, no matter how complicated g of x is. The derivative of cotan g of x will be minus cosecant squared of g of x multiplied by the derivative of g of x, right? So it's so important to understand this process going from a basic derivative and then using chain rule to find a derivative of cotan of anything like that. In this case, our anything is n times theta. So let's see how this goes. We're going to do the derivative of cotan of whatever. So it'll be minus cosecant squared of this thing multiplied by the derivative of that thing, right? And what is that thing? It's n theta. I guess it's a little bit bad style to mix the dy notation with the prime notation, but that's not that big a deal. So let's continue. We really are done because, well, this 3 in the minus, I can just write minus 3. And over here, derivative of n theta, this is a derivative with respect to theta, so this is kind of like the derivative of nx. And when you have a constant in front of nx, when you have a constant in front of x, the derivative is just a constant, right? So the derivative of that is just n. I hope that's okay. You know, just like if I have the derivative of 5x, the derivative of that is 5, right? If I have the derivative of nx, the derivative is n. If we're differentiating with respect to theta, the derivative is n as well. So that's why I'm writing n there. And just to make it look nice, why don't we pull the n to the front with the minus 3? And there we go. That's our answer. So this one maybe looks a little bit more abstract, but it's not too bad.